Uh, Fine. So let us continue. So till now we have covered almost half of the section of the syllabus. We have covered the integration part. Prior to that, we have gone for the system of linear equation, and also we have gone for the interpolation and extrapolation. Okay. So we will start with the new topic. This is very important topic as far as your engineering is concerned. So, what happens, especially I'm giving you an example of structural engineering right now, but it is also applicable for other engineerings also. So, for example, if I take an example of structural engineering, so let us say if you want to analyze a simple frame, which is like this, okay. So, so it is like this. I'm just going for only 2D just for demonstration purpose. So now there are different methods to solve this particular problem. So our interest over here is to find out what is the shear force diagram and what is the bending moment diagram. Okay. Now to solve this, the two different popular methods which are still being used for this structural analysis. One is the matrix method. Okay. Okay. And second one is the finite element method. Okay. So both the methods, I think some portion will be covered at your undergraduate level, probably matrix method. You may be having some exposure probably in your electives. Even in finite element method, the introduction part may be covered in some of the electives. Okay. So all I'm trying to say over here is whenever you are going for some advanced analysis, you will always end up with a system of linear equations. Okay. So in both the methods we have, you will generate a stiffness matrix, and ultimately you are going to get a equation which is like this, that is k into delta. Okay, so this should be curved base equals to the force. Okay, where this is nothing but stiffness matrix. Okay, and this is nothing but unknown displacement. Okay, and this is nothing but the force. Okay, so this is a typical system of linear equation, and today we are going to solve what are the different methods. We are going to study what are the different methods to solve the system of linear equation. Okay, so the system of linear equations, like this particular matrix, let us say for this particular problem, you have 3 degrees of freedom over here, and here 3 degrees of freedom over here. Now since this is a fixed support over here and this is a fixed support over here, so displacement is not at all possible. Okay, so at each joint you have displacement possible in x direction, displacement possible in y direction, as well as the rotation which is possible in the z direction, assuming that this is your x, this is your y, and this side is your z. So rotation is also possible. So if you use either finite element method or maybe matrix method, this stiffness matrix will be created. It is of size 6 by 6. Okay. So for this particular problem, okay, so you will have a big matrix which is of size 6 by 6. This will be multiplied by some unknown displacements. Okay. So displacement may be x1, y1, theta 1, then x2, y2, theta 2, so on, equals to, you will be having some values of forces. Okay, so this part will be known, this part will be known, but this part is unknown. So this is a typical system of linear equation. So in terms of mathematics, we can write it in form of x, sorry, a into x equals to, say, b. Okay, so this is exactly the same form. Now you just try to imagine that for a simple beam which is having two columns and one beam, you are going to end up with a matrix of size 4 by 4. So if I add on the same structure, if I add one more bay which is like this, okay, if I add one more bay which is like this, so this is going to create a simple room kind of a structure where you have four columns. Okay, But if you try to analyze the entire structure, here there will be 3 degree of freedom, here it will be 3, here it will be 3, and here it will be 3. So here this equation will be having 12 by 12 matrix size. Okay. Now on the same structure, if you go for one more floor, for example, okay, so this one more floor is going to create another degrees of freedom over here, and ultimately this matrix will be exactly the double of that. Okay, so this will be 24 by 24. Now you just imagine these are just two rooms. Okay, but when you take the actual plan or any structure, so plan can be maybe like this. Okay, so you have one hall, one bedroom, and so on. And if you develop this plan in 3D, so you will end up with a matrix maybe starting from size 200 by 200, and it can go up to any size. It totally depends on the number of stories and number of joints which are available in that particular structure, right? So basically what I'm trying to say over here is you have to solve a system of linear equation where the number of equations are very very large. Okay, so it can be simple 6 by 6, or it can be even 200 by 200. Okay, so usually we are not solving these equations with the help of manual calculations. We are using computers for that. Okay, now just for your information, if you want to analyze any building, okay, so there is a one building. Okay, so if you want to analyze this building, let us say if computer is taking 10 seconds of time. Okay, for example, a computer is taking only 10 seconds of time. Out of this 10 seconds, roughly 9.9 seconds they are used to solve only this equation. Okay, otherwise to generate, how to generate this equation, how to generate this force matrix, they are going to take a very fraction of seconds. So almost 99% of the total time is consumed in solving the system of linear equations. Okay, so that's why as far as structural engineering is concerned, solving the system of linear equation is very very important. Okay, now you just imagine for computer it is taking 10 seconds. Okay, so for computer if it is taking 10 seconds, then for human being if you do the calculation it may take months. Remember this, it may take even months. So you just imagine what kind of problem we are dealing with. Okay, so our objective over here is to reduce this computational time as well as reduce your manual calculation time. So if you are able to get the solution with a faster method, and that to a very quick method, and that to a very accurate method, then the life will be very very easy, isn't it? So for this purpose we will be studying this particular chapter wherein we are going to study different methods, right? Now to analyze this system of linear equation, there are two types. Okay, the first type, it is called as direct method. Okay, let me write down DIRECT. And the second type is iterative method. Okay, so we are going to study two or three direct methods, and we are going to study two or three iterative methods to solve the system of linear equations, right? Now the difference between direct and iterative methods is like this. So in direct method, the steps, okay, steps are defined. Okay, then also the number of calculations, they are also defined. Okay, irrespective. Sorry, recording has been already started in the other meet. Okay, so don't worry about that. But still, let me check. Yes, I have already started recording, so no worry about that. Okay. Anyway, so I was telling you that in the direct method the number of steps are defined. Okay, so irrespective of your matrix size and the elements which are there in the matrix, you have to perform that calculations. Okay, so it is completely fixed. Because of this, what is going to happen, your the dependability of the time is not at all there. Okay, so irrespective of if you are solving, let us say, 4 by 4 matrix, so whatever steps you are using for one 4 by 4 matrix, same steps you will be using for other 4 by 4 matrix. everything will be same, only thing is the values will be different. Okay, so calculation or the time required to solve a 4 by 4 matrix using direct method, it will be exactly same. But in case of iterative methods, okay, so here the iterative methods, your time can vary. Okay, so it's a iterative method, so you are going for first iteration, second iteration, third iteration. Now this is totally depending on your matrix. So if you are solving one problem, it is let us say 4 by 4 matrix, you may get correct solution only after let us say 4 iterations. But if the data is changed, if it is the new data is also having 4 by 4 matrix, but it may take even 10 iterations to solve the problem. Okay, so iterative methods, they are slightly different than the direct method. And they are basically, if you compare the iterative method with the direct method, they are depending on the data. So if data is simple, you will get solution quickly. If data is complex, you will get solution some after, after many iterations. Okay, but comparatively, if you see the iterative methods, they are very good as far as structural engineering is concerned. Okay, why I'm specifically mentioning structural engineering? Because the type of the matrix which we generally get in the finite element method, or maybe a direct stiffness method, or maybe even a matrix method, in that the nature of the matrix is such that for that matrix the iterative methods are more suitable. Okay, so let us quickly see the Gauss elimination method. I think Gauss elimination method तुम लोगों का मैथ्स में हुआ है कि नहीं हुआ? Anyone? Please respond. Was it covered? Yes, students, was it covered?
No, sir.
पक्का? मैट्रिक्स अलजेब्रा वगैरह हुआ है क्या तुम लोगों का?
हाँ सर, फर्स्ट ईयर में हुआ,
लेकिन गॉस एलिमिनेशन नहीं हुआ. Okay, so fine. We will continue. So in Gauss elimination method, what exactly it is done, we will see. Okay. Uh, so let me draw a simple line over here. Okay. So let us say I have a matrix. Okay, like this. Let me take example of 3 by 3 matrix. Okay, so this is one value, this is second value, third value. So this is a 3 by 3 matrix. Okay, so this is 3 by 3 matrix. Okay, so there can be any values. Okay, then this you have unknowns, let us say x, y and z, these are unknowns. Okay, and then you also have some values over here. Okay, so now in this particular method, what exactly it is done is like this. So in the first step, what we are going to do is we are going to convert these two elements as 0. Okay, so how to do that, that I'll tell you. So as a result of this, what will happen after the first step, these two elements, they will be becoming 0, and then these values, they will change. Okay, so this is the first step. Accordingly, this unknown, they are going to remain constant. Okay, and here you will also have some values which are like this. Okay, now in the second step, we are going to convert this as 0. Okay, so as a result of this, what you are going to get is a matrix which is like this. Okay, and you will have unknown as x, y and z, and here you will be having some values. Okay, so now if you observe very carefully, what I have done, I have reduced the given matrix into a upper triangular matrix. Okay, so upper triangular matrix means what? There are non-zero elements in the upper triangle and there are 0 elements in the lower triangle. Okay, so if you see a 3 by 3 matrix, okay, let me draw a 3 by 3 matrix once again for you. So you have 1 2 3, 1 2 3, there are some values, it can be 0, it can be non-zero values. Okay, so as far as the matrix is concerned, this is called as a diagonal of a matrix. Okay, this particular portion is called as the upper triangular matrix. Okay, upper triangle of the matrix, and this is called as the lower triangle of the matrix. Okay, so this is lower okay, and this is upper, okay, and as far as this part is concerned, this is called as diagonal. Okay, so what we are trying to do over here is, so there is a matrix, okay, so there are some values over here, okay, so we are trying to convert this into a upper triangular matrix by eliminating the lower triangular elements. Okay, so now how to do this? So there is a standard procedure for that in the Gauss elimination method. Okay, so just to demonstrate this, what we are going to do is we will take a simple example. Okay, let me take only 3 by 3 matrix so that your calculations can be reduced. Okay, so here let me take a example now. Okay, so I don't have the answers to the this example, so you have to help me out while getting the solution. Okay, so I have three or system of linear equation which is having three equations. Okay, one is say 2x plus 3y plus z equals to 9. This is equation number 1. Okay, the second equation is x plus 2y plus 3 times z equals to 6. So this is the second equation, and the third equation is, this is 3x, okay, plus y plus 2z equals to 8. So this is the third equation. Okay, so now there are three equations and there are three unknowns. Unknowns कौन कौन से हैं अपने पास? X is unknown, y is unknown and z is unknown. Okay, so now we have to find out these unknowns by solving the given three equation. Okay, so ideally if you don't know the Gauss elimination method, what we are going to do is, we are going to, for example, what we will do, we will take these two equations. Okay, we will try to establish, or we will eliminate either probably x, and then we are trying to establish a relationship between x and y and z. So y can be replaced in terms of z, that can be substituted in the other equation, and then you can solve the equations so that you can get the values of x and y and z. Okay, but this is possible if you are using only three elements. Okay, but if there are more number of elements, it will be very very difficult. Okay, so now let us try to find out the solution of this using Gauss elimination method. Okay, so for solution purpose, I am going to draw the augmented matrix. Okay, so this is called as augmented matrix. So in the augmented matrix, I am going to write down the coefficients only. Similar lines, I'll be writing the second equation. So the second equation, so the coefficient of x is 1, coefficient of y is 2, and coefficient of z is 3. So that now if you go for the multiplication of this row with the same column, what you should get? You should get this as 6. Okay. Secondly, I can have the third equation also. This is coefficient is 3, this is 1, and this is 2. And accordingly, if you multiply, so you should get the value of 8. Okay. So this is a kind of a matrix representation of the given 3 equations. Okay, I hope this is clear to everybody. ठीक है?
Yes.
Right? Okay, so now this is a simple representation, but now I am going to draw the augmented matrix of this. Okay, so augmented matrix, it can be written in a very simplified way. So I just write this as 2 3 1, and this is 1 2 3, and this is 3 1 and 2. Then in the augmented matrix I just have to draw a simple dotted line, and then I am going to write down the coefficients, which are 9 6 and 8 over here. Okay, so this is what we call it as a augmented matrix, right? So now, as far as Gauss elimination method is concerned, what we have to do is we have to eliminate this component and this component, so that the triangle will become the upper triangular matrix. Okay, so now to begin with, let us focus on this particular element. Okay, so if I consider this as matrix A, okay, so let us consider this as matrix A. Okay, this as vector X. Okay, so vector should be written in a curly braces. Okay, and equals to, this will be, let us say, vector B. Okay, so if I call this as matrix A, this particular element will be called as A11. Okay, sorry, A21, that is the second row and first column, isn't it? So this is nothing but A21. So basically what I have to do, I have to convert A21 equals to 0. Okay, so how to do this? Okay, so for this purpose, whenever you have to eliminate any of the element, you have to refer to the first equation. Okay, which is coming in the diagonal for the elimination purpose. Okay, so this is belonging to row 1 and this is nothing but your row 2. So if I want to convert a12 equals to 0, then what should I do? I should go with row 1 will be equals to, sorry, row 2. Okay, row 2 will be equals to row 2 multiplied by 2 minus row 1. Okay, why I am going for multiplied by 2? Because if you see, uh, this, the expression or the value which is over here, this is nothing but 2. So if I go for this particular expression, so what will happen to a12? So a12 will be 1 multiplied by 2 minus row 1. So row 1 is over here, so this is going to become 0. Okay, but the same operation has to be done over here, as well as over here. Okay, so this is nothing but a22 now. Okay, so this value is nothing but a22. So a22, you have to follow the same expression, that is r2. So in r2 we have this, that is 2 multiplied by 2 minus 3, because 3 is over here. I don't know, there is probably network issue, but I think you can guess the values from the equations. I think the screen is displayed over there, है ना? Anyway, so is it okay? समझ में आ रहा है? Okay. Yes, students, am I audible?
Yes, sir. Sir, A22 will be 1.
Probably there is a network issue. Anyway,
Value of A22 will be 1.
no, value of a22. So when I am saying row operation, so entire row has to be transformed. Okay, so a22 value is basically 2 over here, isn't it? So this will be 2. So r2, so r2 into 2 minus r1. Okay, so when I am talking about the second column, so the r2 value, the row 2 value is 2 multiplied by 2 minus 3. So similarly, if you go for I think this is 2 3, यहाँ पर मैंने शायद गलत लिखा है, this is not 1 2, this is a21. Okay, a21. Okay, so a23.
Sir, A22 should be 1 because 4 minus 3 is 1.
Sorry,
A22 should be 1.
a22 1 क्यों आएगा बेटा?
2 into 2 4 and 4 minus 3 1.
ओहो सॉरी, अच्छा ये वाला मिस्टेक किया मैंने, सॉरी माय मिस्टेक. ओके दिस वन, ये कितना आएगा? 1 ना? ओके 1 आएगा, सॉरी सॉरी, ओके थैंक यू. हाँ, so A23, so now I am operating the third column, so this will be something like the same term, so this will be 3 multiplied by 2 minus क्या आएगा तुम्हारा 1. Okay, so 3 into 2, so this is 6 minus 1, so this will be 5. Okay, now the same has to be done over here also, that is the B matrix. Okay, so here the same has to be done, so what will happen, so this will be say B2. Okay, ये तुम्हारा क्या है बेटा? B2. Okay, so B2 should be now becoming 6 multiplied by 2 minus 9, ये कितना आएगा? 3. Okay, just give me a moment, I am getting an important call. Okay. Hello. Hello. Yes. Okay, students, are you there? Okay. Let me. Oh, okay, fine. Sorry for that. It was an important phone call, so I have to take. Okay. Anyway, so ultimately, we are going to get this matrix. So as a result of this, the given equation, which is this one, it will take a new shape. Okay. So this will be 2, 3, 1. I'm again drawing the augmented matrix. So this will be 9. So your second row is going to change completely. This will become 0. This will become 1. This will become 5. And this will become 3. The third row is going to remain same. This will be 3, 1, 2, and 8. Okay. I hope you have understood this.
Yes, sir.
Okay. So as a result of this, what has happened over here is we have converted this to 0. Okay, so now our objective over here is to convert this to 0. So now I have to do the operations on row number 3. Now for doing operations on row number 3, again we have to use only row number 1. You are not supposed to use row number 2. Okay, always remember we have to refer to a row which is there in the diagonal. So in the diagonal of the first row, the diagonal row is nothing but your R1. Okay, so now if you want to convert this 3 with this 2, तो कैसा करोगे?
Sir, R3 equal to 2R3 minus 3R1.
Okay, so what I am going to do over here is I am going to write down R3, okay, multiplied by, okay, so I have to convert this into 2. So I will just go for a multiplication of 2 by 3 minus, I will say R1. It's a very simplified way, isn't it? So this is nothing but a coefficient. Okay, so for every operation, value of these coefficients will be different. Okay, so now here I have to go with one by one. So the first element will be something like A, third row, first column. So I am talking about this particular element. This is A, third row and first column. So here A, third row and first column will become, this will be 3 into 2 by 3 minus the R1 value is nothing but your 2. So this is going to become 0. Okay. Similarly, if you go with A, 3 2. So A32, the element is 1, okay, multiplied by the coefficient which is 2 by 3 minus the third is this one, okay. तो ये कितना आएगा बेटा? This is 2 by 3, not 2 by 2. How much is this? Can someone tell me?
Minus 7 by 3.
Minus
7 by 3.
7 by 3. Similarly, A33 will be, this will be 2 into 2 by 3, then minus, यहाँ पर क्या आएगा? 1. Okay. How much is this?
1 by 3.
1 by 3.
3.
And lastly, you will be operating on B3. Okay. So B3 will be 8 into 2 by 3 minus this will be 9. How much is this?
Minus 11 by 3.
Minus 11 by 3. Okay. So as a result of this, this given matrix will take again again a new shape. So this is 2 3 1, then we have a dotted line, this will be 9. The second row will remain same because we have not done any calculations in this step for the second row. Third row will be completely different, so this will be 0, this will be minus 7 by 3, this will be 1 by 3, and this will be minus 11 by 3. Okay, so have you understood this?
Yes, sir.
ठीक है. Now see, till now we have just converted the first column to 0, but the entire matrix is still not yet converted to the upper triangular matrix. This particular element is still non-zero element, okay. So we have to convert this into a 0, okay. So again, in this case, you have to operate on R3, okay. But what will happen if you use R1 over here? Because if you do some operation, okay, so R1, if you use some operation like R3 equals to R3 into some coefficient, it can be any coefficient minus R1. If you do this, what will happen to this particular element? This will be something like 0 into some coefficient minus 2, isn't it? So this will become a non-zero value. ओके, तो यहाँ पर क्या आ जाएगा? यहाँ पर कुछ तो भी एक नंबर आ जाएगा, है ना. सो वी डोंट वांट दैट बिकॉज जस्ट नाउ वी हैव कन्वर्टेड दिस इनटू 0 एंड वी विल बी इन ट्रबल. So therefore, whenever you are using the operation, you have to always choose the corresponding equivalent your row. Okay, so I'm just erasing this so that now if you use R2 in place of R1, your life will become simple. Okay, because okay, let me erase this. So here, if you use R2 in place of R1, things will become simple. So always remember, if you are operating this particular column, okay, so you use corresponding row. So earlier, if you see, we have operated on this column, that's why we have taken only row 1. Okay, so if you are operating the third row, then you have to use the if you are operating the third column, you have to use the third row. Okay, so like this. So now what I will be doing over here, if you want to convert this matrix, this particular element equals to 0, so this is the third row, okay, but the second column. So I need to go for the operation which is like this. R3 will be R3 into some coefficient minus R1. Okay, now what will be that coefficient? Can anybody tell me?
Sir, it should be R2.
Oh, sorry, R2, not R1, R2, my mistake. What coefficient should I write? Bolo? Bolo?
3 by 7. It should be reciprocal.
Yeah, it should be reciprocal. Okay, just for sake of simplicity, if you refer the previous one, what I have written this coefficient, this is 2 divided by 3. What was 2? 2 was nothing but this coefficient. And what was 3? It was this coefficient. Okay, so similarly, on the similar lines, you can write this. So this will be something like the first row is nothing but your 1, and divided by this will be minus 7 by 3. Okay, So always remember, this is a coefficient of the same row, that is this row, okay, and this is the coefficient of the second row. Okay, if you see about the coefficients, okay. So as a result of this, what you are going to get a expression which is like this. So your r3 will become r3 into, this is 1 upon minus 7 by 3, so this will become minus 3 upon 7 minus r2. I hope this
Sir,
is clear to everybody.
Yes.
sir, we do it more simpler, sir. If we do R3 plus 7 by 3 R2.
Sorry.
Sir, if we interchange by
Yeah, you
doing
can do that
R3,
one also. I got the point. So you can operate with that one also, okay. But I'm just telling you how usually it is done, right? Fine. So you are basically multiplying the r2 with 7 by 3 and then adding it, okay.
yes.
वो भी कर सकते हैं, but when you go for programming, because generally this is a 3 by 3, you can do it manually, but if you see the programming point of view, your equation cannot be sometimes plus and sometimes minus, isn't it? So that should not happen, that's why we are going it in this way, okay. Anyway, but you can do it that one that way also, there is no issue in that, okay. So now let us work on the all the coefficients of r3. So row 3, the first coefficient is a31, okay. So this I'm talking about a31, which is over here, okay. So ultimately what is going to happen over here, this will be 0 into minus 3 by 7 minus 0. So this is not going to change, this is going to remain same, okay. Then if you go for a third row, second column, so this is r3 will be like minus 7 by 3 into, you have minus 3 upon 7 minus, okay, minus you have r2. So r2 is nothing but your 1, and ultimately this will get cancelled, this will get cancelled, this will also get cancelled, this will be 1 minus 1, it will be 0, right. And nextly a33, so a33 you have 1 by 3 into, the coefficient is minus 3 upon 7 minus the corresponding this is 5, okay. So I think ये कितना आएगा बेटा, someone please tell
Minus
me.
36 by 7.
Sorry.
Minus 36 by 7.
Minus 36 by 7, okay. So now lastly you have to operate b3 also, okay. So b3 is minus 11 upon 3 into minus 3 upon 7 minus, यहाँ पर क्या आएगा, यहाँ पर क्या आएगा, yes 3, because we are operating it with row number 2, okay. So how much is this,
Minus 10 by 7.
minus 10 by 7, okay. So as a result of this, your final augmented matrix will look like this. This will be 3 2 1, okay. This is 9, the second row will always remain same, so this will be 3, and this will become now 0 0. This is minus 36 upon 7, and here this will be minus 10 upon 7, okay. Have you understood this?
Yes, sir.
So now you see, after 3 steps, your lower triangle is becoming now 0, okay. So now if you rewrite all these this matrix in terms of equation one more time, so you will end up with 3 equations, okay. So this is something like 2x plus 3y plus z equals to 9. This will be your equation number 1. But if you see the second equation, you have 0 over here, then you have 1y plus 5 times z equals to 3. This is the second equation. And third equation, you have 0 plus 0 plus, or rather I should write minus 36 upon 7 times z equals to minus 10 upon 7. This is equation number 3, okay. So now you have 3 equations which are now converted into another 3 equations, in which you will find in the third equation the coefficient of x and y are 0. In the second equation, the coefficient of x is 0, and first equation is still same as the given equation. Okay, so now from this point onwards, you have to use method of back substitution. Method of back substitution. Okay, so in the method of back substitution, first of all you have to choose the last expression. Okay, so the last expression says, that is expression number 3, it says 36 upon 7 into z equals to minus 10 upon 7. So if you solve this, I am sure you will be getting the value of z. Z कितना आ रहा है?
5 by 18.
1277.
नहीं, 5 by
18.
18. Okay, so this is the answer of z. Okay, and how it came? It came from the method of back substitution, so we have used the third equation. Okay, now in the method of back substitution, you have to always go in the reverse order, so I am going for the second expression now. Okay, so the second expression says 1y plus, you have 5z equals to 3. So as a result of this, I can say 1y plus 5 times z. So z is nothing but 5 by 18 equals to 3. Okay, so if you solve this, you should get the value of y. How much is this y?
29 by
29 by 18.
18. 18.
Okay, so this is the value of y. And lastly, you have to solve the equation number first. Okay, so this equation is nothing but 2x plus 3y plus z equals to 9. So as a result of this, you can say 2 into x, x is unknown, plus 3 into y, y is 29 by 18, plus z, z is 5 upon 18 equals to 9. So if you solve this, you should get the value of x as
16 by 9.
16 by 9. Is it correct?
Yes, sir.
अब ये करेक्ट है कि नहीं है, वो कैसे पता चलेगा? ठीक है, so now you should know that these three unknowns, that is x, y and z, we have the values. Okay, but if you see the original equation, this is the original equation, what it says, if you substitute the values of x, y and z, चाहे वो आप इस इक्वेशन में सब्स्टिट्यूट करो, चाहे आप इस इक्वेशन में सब्स्टिट्यूट करो, चाहे आप इस इक्वेशन में सब्स्टिट्यूट करो, after substituting the values of x, y and z, you should get the corresponding values over here. Okay, but to check or to verify this, I won't be using equation 1, because if you remember, we have calculated the value of x using the first equation. Okay, so other than the first equation, you can use or you can verify these values using either equation number 2 or equation number 3. Okay, so let us try to verify this value using expression number 3, which is 3x plus y plus 2z equals to 8. So let me write down that expression. So the earlier equation, that is in the problem, okay, equation 3 was क्या था ये? 3x plus y. So this is 3x plus y plus 2z. Okay, plus 2z equals to 8. Okay, so if you substitute the values of x, y and z, which you have just now calculated in the given equation, you should get the correct answer. Okay, so let me write down. So this is 3, the x value is 16 upon 9. Okay, plus 1, y value is 29 upon 18. Okay, plus 2 times z. So z, I think it is 5 by 18. Okay, and this must be equals to 8. Please cross check this whether it is 8 or not. हाँ, तो इसका मतलब तुम लोगों ने कहीं तो भी गड़बड़ करी है. Value of x is coming out to be 30.
35 by
Okay, let me check. 35 or 25?
35.
35 by 18.
In 1 8. Yes,
One
sir.
8. Okay. So still you check कितना आ रहा है सब्स्टिट्यूट करके. दिस शुड बी
Yes, sir.
35 by 18.
30 Tara.
आ रहा है अभी बराबर.
Yes.
ठीक है. Still if you want
Yes.
you can check your equation 2. Okay, don't use equation 1, you use either equation 2 or equation 3. It says 1 2 3 equals to 6. Okay, so this is 1x plus 2y plus 3z equals to 6. Okay, so this is 35 by 18. Okay, plus 2 times y, so y value is 29 upon 18, and plus 3 times z is 5 upon 18, and this must be equals to 6.
Sir, it's equal to 6.
It's equal to 6, right? Okay, so this is how the problem has to be solved, and this is how you have to check whatever answer you are getting whether it is correct or not. Okay, so अच्छा हुआ किसी ने गड़बड़ की थी कैलकुलेशन में. ओनली बिकॉज ऑफ दैट वी कुड एबल टू फाइंड आउट वेदर द एक्स आंसर इज करेक्ट और नॉट. ओके, तो अगर तुम लोगों को लगता है कि इफ देर इज समथिंग रॉन्ग एंड यू आर नॉट गेटिंग द करेक्ट आंसर, in that case you have to check all the calculations. Okay, that is the only way to find out the mistakes. Okay, so now I hope this is clear to everybody with this method. ठीक है. So we will stop over here. We will continue tomorrow with the same method. Okay, because this method is not covered. So first time you are learning this method, so we need to have a practice. So in the next class we will be covering same type of problem, but this time or next time we will be going for 4 by 4 matrix. Okay. Okay, then let me stop the recording.